In lesson 3.5 example 2, we're proving the identity. So this is where you want to pick one side to start on, and you want to manipulate it using your trig identities and algebra to look like the other side. You can only work on one side. You cannot go back and forth on either side of the equal sign. And you want to try to work on whichever side looks like it uses a property. Like here I've got a 1/2 x, so I'm going to start on this side. This doesn't have anything cool about it, so this is pretty simple. You want to start on the more complicated side where there's stuff you can actually do. Normally we like to change our tangents. So let's change tangent into sine over cosine. And that is a quotient property if you're wondering where I'm getting it from. Tangent is sine divided by cosine. And there's no symbol between your tangents, so that means we're multiplying. I'm going to express that with parentheses. And I'm going to change my tangent 1/2 x into, because there's a half on it, you want to look at your half angle properties. So for tangent 1/2 x, I've got three options here, and I need to choose which one is best. So you've got a choice to make. If we want secant, we need to figure out how we're going to make that. Remember, secant is made out of cosines. So, and I'm talking about here, reciprocal. Secant is made out of 1 over cosine. So we want this cosine to stay on the bottom, if we can. What we do want to get rid of is the sine. We don't want sine, because sine doesn't make secant. So we look at these and we think, which of these would keep cosine but get rid of a sine? This is a little too complicated for where we're headed, because you don't see a radical or anything weird. Here, if I put this one on the bottom, yeah, I'm going to get a cosine on the bottom, but I'm also going to get a sine on top, and I don't want any more sines on top. I want to cancel. So this is the one we want to use, because sine is on the bottom, and it would cancel out the sine that we don't want. And we're going to have cosines in the answer, and there's subtraction here, and we can see that there's subtraction at the end. So this is the one we want to use. So the first step in this proof was to pick a quotient property and a half argument property to substitute in for your tangents. And now we just have some algebra. We've got sine cancels with sine because we're multiplying. And that leaves me with 1 minus cosine over cosine. And we're really close to the end. If we just have to figure out how to get that secant, how to get that minus 1. If you think about splitting these fractions, you can see how we get to the end. If we split them, we now have a 1 over cosine, which makes secant. And that's what I pointed out before, reciprocals. 1 over cosine will make secant. So we've got secant. And then cosine divided by cosine, anything divided by itself is 1. And so we've shown that we've taken one side and manipulated it into the other, so they must be equal. Here we've got another proof, and obviously the more complicated side is over here with all the 1/2 arguments. And we just want to choose, we want to figure out how we're going to cancel these things. And if you look at your properties, we've got cosine. That's really complicated. And so is the sine. We don't want a bunch of radicals in the problem. It could work out if the radicals canceled and the halves canceled, but you're still going to have, you're going to end up getting like a 1 plus cosine over 1 minus cosine, and I'm not sure that that's really that helpful to you. One thing that I notice here is that the top is conjugates with the bottom. So what if we use conjugates on this one? So what I'm going to do, and what we normally do, is we multiply by conjugate of the bottom. So I'm going to start by writing my given. And maybe I should write smaller than this. This is a pretty complicated process. So I've got here, the conjugate of the bottom will be cosine 1/2 v plus sine 1/2 v. Remember, conjugate is the exact same thing, only you just change the middle symbol. And it creates this difference of two squares so that we can cancel out some terms. Whatever you do to the bottom of a fraction, you have to do to the top. So this is not conjugate with the top. But because we're doing conjugate on the bottom, we have to also do the exact same parentheses on the top. And then I've got a foiling problem here. So I'm going to distribute. I've got now cosine squared 1/2 phi. And then I've got positive cosine 1/2, sine 1/2. Then I'm going to distribute my sine. I'm going to have another positive cosine 1/2, sine 1/2. And then I've got sine times sine, so I'm going to have positive sine squared 1/2. All over. Bottom we do the same thing. It'll be cosine times cosine is cosine squared. Cosine times sine is positive cosine sine. Then I've got negative sine times cosine, so negative cosine 1/2 phi, sine 1/2 phi. And then I've got negative sine times positive sine, which is negative sine squared 1/2 phi. So then we can think about some algebra things. What can we put together algebraically? On top, these are matching terms. So there's two of those, and we are adding. So there are now two of those. So I'm going to write that with a big 2. Cosine 1/2 phi, sine 1/2 phi. On the bottom, these are like terms, but they're opposites. So those cancel. Those make 0. That's like saying plus 2 minus 2. They just become 0 and you don't need to put the 0. So on the bottom now, we've got just cosine 1/2 phi from front, and then minus sine 1/2 phi from the back. So we've got it down to this, and then we want to think, is there anything else we can do? Do we see any properties here? One thing I notice is that I've got cosine squared plus sine squared. These two things on the ends are your Pythagorean property, even though there's a half on them. It doesn't matter what the theta is. We've got this property right, I lost it already, right here. Cosine squared plus sine squared equals 1. So all of the things I just circled equal 1. Plus. Then I've got a 2 times sine times cosine. This middle thing is a property. That is a double angle property, which we have right here on the note card. Sine of double A is 2 times sine times cosine. It doesn't matter what the A is. So here I've got 2 times sine times cosine. So that whole thing right there becomes sine of double A. Sine of double A. But what is the A? The A here is a 1/2 phi. Sorry, I'm kind of bleeding into the denominator there. On the bottom, I also have a property. Now this looks Pythagorean, but there's a minus. See, this has cosine squared plus sine squared. This one has minus. The minus tells you it's a double angle. That's cosine double A is cosine squared of A minus sine squared of A. And the A here, again, is a 1/2 phi. So this whole bottom will change into cosine double A, which is 1/2 phi. Then we look at some more algebra that we can do. Double 1/2, the 2's cancel, so we just get phi. Same thing here, 2 times 1/2 is 1, so we don't need those 2's. So that really simplified it, and we got down to just phi instead of all these half phi's that you see. And then we just got to figure out how are we going to make secant and tangent. Well, secant is made with a cosine on the bottom, and we've got that. And tangent is made with a sine divided by a cosine, and we've also got that. So all we need to do is just split this into two fractions. So I've got 1 over the cosine plus sine over the cosine, since they have common denominators. And that creates secant, which is a reciprocal property. And that creates tangent, which is a quotient property. And we have proved that the left side equals the right side.